All right, this is Unit 3 Trig test review, guys. This is the last test of quarter number 3, so let's get started. So for number 1, we're finding the period and the amplitude of each function. So first for the amplitude, remember the amplitude is the height of the wave from the midline. So this was a mistake a lot of you made on the quiz. You want to measure the height of that wave from the midline. In this case, it's not the x-axis, so you're measuring the height right here. So we're essentially measuring from 1 to 2 on the y-axis. So the amplitude is simply just 1. The period, of course, there's a formula to find the period if we're given the equation. So you could use that here, or you could just simply, it's the distance, it's the length of one wave. So the wave starts repeating itself from this point to this point. So we're just finding that length. The mistake a lot of people made on the quiz for this problem was to say the period was 2. But if you look, this actually lines up with -1 pi. And this one lines up with 0. And the distance from -1 to 0 is just 1. So that's why our period is 1. Of course, it's 1 pi because all of our units in this problem are in terms of pi. So that's the period for this problem. We had a similar problem on the quiz like this. This was one of the more missed questions. Overall, the quizzes were good, but this was a commonly missed question. So same thing here on the second one, find the amplitude and the period. The amplitude, again, is the height of the wave from the midline. It gets a lot easier when that midline is the x-axis, so we can just measure that length right there to find our amplitude. So the height is +3. Remember, amplitude and period are always positive because they're distances. And the period, again, just find where it starts to repeat itself. You can find that in a lot of different places. So the period is distance from that point to that point. And if you notice, of course, it's empty right here. They've gone from 0 to +1 pi. So if they've skipped 1, that means they've skipped 1/2. So each little square, they're counting by halves here on the x-axis. So that means this one right here is 1.5 pi. That means this one right here is 2.5 pi. So now we can pretty easily find the distance, the length from 1/2 to 2.5. You could always subtract those in your calculator, but that distance right there is 2. Again, it is 2 pi. Since we're talking, since everything's in the terms of pi. So that's our period. So that's period and amplitude. If you have any questions, let me know. Real quick, one last one. Find the period and amplitude of this graph. So again, the amplitude, we can find that pretty quickly. It's the height from the midline. So the amplitude you should have gotten was 4. And the period, the distance from this point to this point. Of course, if we look down here, it lines up with 2/3 and 4/3. And if you don't know, put 4/3 minus 2/3 in your calculator to see what that length is. 4/3 minus 2/3 is just 2/3. So that's the length of each wave, 2/3 pi. So that's our period for that third graph. All right, so number 2, we're finding the period and amplitude of each function. This time we're not given a graph, we're given the equation. So we can use the simple formulas I've shown you how to find the amplitude and the period of a function. The A, that represents the amplitude. So for 2A, the amplitude is +1/2, because again, amplitude is always positive. And then the period is the B value, which in this case is 5. Sorry, it is 2 pi divided by the B value. And 2/5 does not reduce, so we could leave our answer as 2 pi over 5. So this graph would repeat itself every 2/5 pi units. And that's what you're doing on B, C, and D, really, for all of these. Go ahead and try these real quick. I'll pause it, let you try it, so you get the same answers as I got. So there's the answers for parts B, C, and D. Take a moment, review those. Let me know if you have any questions. All right, so number 3, these are the long problems that we have to graph. And unless I say otherwise on the test, pretty much these are the values you always want to pick for x, because they're just convenient. They give us a nice smooth curve if you pick these values. Essentially what we're going to do is we're going to count by 1/2. So if that's 0, x is 0, we're going to count by 1/2 this direction. So it's 0.5 pi or -2, and another half. That gives us 1 full pi, and another half, that's 1.5. But in fraction form, typically how we write these is 3/2 pi, and another 0.5, we get 2 pi. And then the same thing in the other direction. So make sure you're in radian mode when you're putting these in the calculator. Anytime you've got pi involved, you want to be in radian mode, not degree. So change your calculator to that mode, and we're essentially going to insert each of these x values for this equation to give us y. I'm going to pause it, let you come up with those, and I'll fill them in, then we'll graph these. So those are your values for y that we'll be working with, and we're essentially going to just graph these points. They don't have anything sketched on the y-axis, so let's make that a +1. We'll make that a -1. So that should be a rough sketch of what your x and y-axis look like. I'm going to erase those just so we have a little bit more space to graph it. And then just sketch the cosine curve. This is one we've done a few times. So that should be what the cosine curve looks like. It's symmetric about the y-axis. And then we can find the period a couple different ways. You can find the period using the formula 2 pi divided by b, or you can find it visually. Either way, the period for this graph you should find is 2 pi. If we use the formula, it's just 2 pi divided by 1. And the amplitude, the height of that graph from the midline, is just 1. So now repeat the process. You're going to use the same values for x for part B. And you're going to repeat that process and see if you can identify what's changed from this graph to your new graph in part B. So hopefully you paused it and you tried this on your own to make sure you got this graph. Your ultimate graph should look like this. Again, make sure your calculator's in radian mode. And you should be able to find the period and the amplitude just like the previous problem. Again, you could use the formula, or you could use the visual definition, just find the length from where it repeats. Either way, again, the period is 2 pi, and again, the amplitude is +1. Now, the key part to this question is what you need to be able to identify is how it's shifted. So the original graph was cosine x, second graph was cosine x +3. So what you should notice is that all of these y values, they've increased by 3 units. And we talked about this before the break, about why they were increasing by 3 units. And it's simply because of this +3 here on the outside. That's our vertical shifter of the trig graphs. So how did it shift 3a? It went up 3 units. Obviously, if it was a -3, a -3 right there, this graph would have shifted down 3 units. You need to be aware of how this number here on the outside shifts the graph either up or down. All right, so for number 4, we're going to figure out, first we're going to figure out the period and the amplitude. So that's nothing new. The amplitude should be the easiest one. The amplitude for this one is just 3/2, or you could say 1.5. The period is 2 pi divided by the b value. The b value is 5. So there's the period, 2 pi divided by the 5. And we just talked about the vertical shift. This number on the outside, that's our vertical shifter. Since it's a -9, it's going to shift this graph. It's going to shift the original. We're talking about how does it shift the original cosine of x graph. It would shift it down 9 units. And last but not least, the horizontal shift. And we talked about this before the break. We've talked about this really all school year. That number on the inside there, that's going to shift us horizontally. And I didn't make you actually go through the process of graphing, just because that would take forever, but this is going to shift it left. Remember, if you see a positive sign in there, it actually means this number here is actually negative. So if you see a positive sign in there, we're actually shifting left pi units. And that's actually what should go in this horizontal shift box. So if we saw a negative sign in there, it would actually shift that whole graph to the right that amount of units. If you haven't already, try B, C, and D. Try these on your own. Make sure you're trying them by yourself before I give the answers. All right, so hopefully you paused and tried those, but the amplitude should be 4. Period is 2 pi divided by the b value, which is 1/2. Or you could say 2 pi divided by 0.5. It does need to be simplified for full credit. So this graph repeats itself every 4 pi units. Just 2 divided by 0.5, that should give you 4. The vertical shift, and that's this number on the outside here. That's easy, just up 6 units. And you look inside here, there's no horizontal shift number on the inside of these parentheses. Really what it is, it's 1/2 x plus 0 plus 6, but there's no reason to write plus 0. It doesn't change anything. So there's no horizontal shift in this problem. However, for part C, we do have a horizontal shift. Before we get to that, the amplitude is 1. The period is 2 pi divided by the b value, which is 2. 2's cross out, so the period is just 1 pi. There is no vertical shift in this problem. It's really a plus 0 out there. It's not shifted the original cosine function up or down. There is a horizontal shift though. Since we see a negative 3 pi, we're actually going to shift right 3 pi units. So I actually want to say that, write it out, right 3 pi units. All right, and then finally D. D, the amplitude is 2. Period is 2 pi divided by 3. Vertical shift is down 1. Horizontal shift, we see a positive, so we're going to shift left pi units. All right, the last somewhat long problem here. The rest are going to go pretty quick. This one says graph the first positive and negative period of each function. So since they want us to do that, we need to first find the period for each of these functions. So we can do that. We can find the period for 5a by taking 2 pi and dividing it by the b value, which is 2. So the period for this first function is pi units. So that means it's going to repeat itself every pi units. So the values we want to pick, again, you could pick the same values we picked for all these problems. You could, but we can actually shorten it a little bit since normally these repeat themselves every 2 pi units. But since it repeats itself every pi units, we only need to count from negative pi to positive pi. I'm still going to count by halves. So negative 1 plus 0.5 is negative 1/2. Add another half to that, you get 0. Add another half to 0, you get positive 1/2. Add another half to 1/2, and you get positive 1 pi. So that's really the only values that you need for this. And that way we'll get the first negative and positive period of this function. So you're going to substitute those values for x and see what you get for y. Again, make sure you are in radian mode. And here's how I'd insert this one into the calculator. So it's y equals 3 times the cosine. I didn't really need to put the multiplication symbol there. You can. Automatically gives you parentheses. There's a lot of different ways to do this. I'll do 2 times, and the first value we're inserting for x is negative pi. So type that in your calculator, and it should give you, I think, 3. Yeah, 3. That gives you 3 for y. And then we're just going to repeat that process, find all those values, graph them. So you should get repeating values of 3 and negative 3, 3 and negative 3. And that is going to give us this wave right here. So we've got the first positive period right there. That's a positive period in the right direction. And we've got the negative period this direction. So that's all we need for the graph. Similar process for part B, but again, you need to find the period first so you know how far to go out with your x-axis. The period for this one is 2 pi divided by the b value, which is 1. So the period for this graph is 2 pi. So that means this one we're stuck with drawing our normal XY table of values chart. Because the first period of the negative direction has to go all the way to negative 2 pi. Then we've got to go all the way to the right side and get to positive 2 pi because that's the first period, positive period for this function. So just insert all those values for x. Pause it to see if you can come up with them on your own. I'll give the answers here in just a second. Just to make sure you're putting them in the calculator correctly. If you want to see one of these, it's the first one. It's 2 times the sine of x. X is negative 2 pi. The minus 3 does not go in the parentheses, so that's important. You need to make sure you close that parentheses before you hit enter in your calculator. And you should get a negative 3. Again, make sure you're in radian mode. Find all those values, graph them, and that'll be your answer for 5. All right, so those should be your values for this one. Or this is a sine function, so that's why it's not symmetric about the y-axis. It's symmetric about the origin. But again, you should notice the first positive period occurs right there, and the first negative period of the function occurs right there. All right, so for the last few problems, these are quick ones. Find the given value for the function below. Remember, these are all in f of x notation. So they give you the x value. You have to find the y value. So the first couple are pretty easy. And probably what I would do also is just go ahead and label some of these values just to make the process go a little bit quicker. So the first one, x is, it wants to know what y is when x is negative 1. So x is negative 1 right here on this graph. Y is equal to 0 at that point. So that's your answer. Part B, x is equal to 6. So find on this graph where x is equal to 6. It's right here. X is equal to 6 at this point. What's the y value at that point? It's positive 1. Then we get bigger numbers. Well, we can go ahead and take care of this one down here, f of 0. When x is 0, find y. So x is 0 right here. That's where x is 0. It crosses the graph here at x equals 0. So the y value when x is 0 is positive 1. To find the other ones, what we need to do first is to find the period of this function. So you need to find, and there's a lot of different places you can find the period, but somewhere where it starts to repeat itself. So that's kind of the, if you look at this, you got the letter M there, sort of, and that's the right part of the letter M. So it repeats itself right here. So the period of this function is 6. It repeats itself every 6 units because the distance from 2 to 8 is 6. Since there's no pi's there at the bottom, we can just say the period is 6. So that means it repeats itself every 6 units. So that means f of 52 is the same thing as 52 minus 6, 46. Subtract 6 more. And you keep subtracting 6 more until you see a value that falls on this graph. So we can keep subtracting until eventually we keep subtracting 6, we get to 4. So we want to find when x is 4, what's y? So in this graph, we can find that pretty quickly. X is 4 here at this point. So when x is 4, y is negative 1. So that means f of 52, since this repeats itself every 6 times, every 6 units, f of 52 is also equal to negative 1. Same idea here for f of negative 39, except this time we want to add 6, since we're in the negative numbers. So if we do negative 39 plus 6, we get f of negative 33. Add 6 more, you get f of negative 27. And you keep doing that until, again, we get a value that we know. Eventually, we keep adding 6. You get f of 3. So you don't have to write all of this stuff with f of negative 33, f of negative 27. I'm just using this to show you. The actual answer is when x is 3. So it crosses right there. When x is 3, y equals 0. So f of negative 39, since it repeats itself every 6 units, is 0. And if you notice, for part F, we've actually already found this answer. Part F was right here. F of negative 27, we already said, was equal to f of negative 39. So it's the same answer as it was in part D. If you're having trouble with that, please let me know. I can help you out with that just a little bit. All right, number 7, the cofunction definitions. The cofunction of tangent is cotangent. Remember, cofunctions, just we're talking about complementary angles are going to be equal. So the sine of 37, if we take 90 and subtract 37, 90 minus 37 is 53. So the sine of 37 should equal the cosine of 53. Here's how to make sure you've got it right on the test, though. Put your calculator in degree mode and type in the sine of 37. If you type in the sine of 37, you get about the decimal 0.601.